A very good morning to one and all. I welcome you all to the next session in the elements of mechanical engineering, that is basic concepts of thermodynamics. Already you studied this thermodynamics in your first year PUC. You know the thermodynamics. What is thermodynamics? In that you know system, system boundary, surroundings, open system, closed system, isolated system. Again, we are discussing here what is thermodynamics. What is system? What is system boundary? What is surroundings? What is open system? Example for open system. What is closed system? Example for closed system. What is isolated system? Example for isolated system. In addition to this, we should study the process, different types of processes, reversible process, irreversible process, state of a system, change of state. After that, study laws of thermodynamics. In that laws of thermodynamics, we are going to study zeroth law, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. Okay. In detail, we study next. First, we are going to study what is thermodynamics. The word thermodynamics is divided into two parts. One is therm and another one is dynamics. In Greek word, therm, which means that energy or heat, and dynamics, which means that the flow. Thermodynamics means the energy flow or the energy transfer or heat transfer, that is called as the thermodynamics. Here heat is a form of energy. Heat is a form of energy. Yes, heat transfer or the energy flow is called as thermodynamics. Next, thermodynamics is the study of energy and its transformation. It's a transformation. It deals with the relation between heat and work. Already you know, heat and work are different forms of same entity called energy. Heat is a form of energy, work is also a form of energy. We can transform one form of energy into another form of energy. We can transfer heat into work, and also we can transfer work into heat. Like that, we can transfer kinetic energy into potential energy into kinetic energy, electrical energy into mechanical energy into electrical energy. All these transformations comes under the thermodynamics. All these transformations comes under the thermodynamics. Whatever the energy, kinetic energy, potential energy, heat energy, internal energy, all these energies comes under the thermodynamics, part of the thermodynamics. All these energies comes under the part of the thermodynamics. If you consider heat energy, it is a part of the thermodynamics. If you consider kinetic energy, that is a part of the thermodynamics. If you consider potential energy, that is a part of the thermodynamics. So that all the energies which are comes under the thermodynamic. Next is, it is the science that deals with matter, energy, and the laws governing their interactions. The applications of the thermodynamics and laws and principles are found in all the fields of energy technologies. For example, in steam and nuclear power plants. In steam and nuclear power plants, we are using thermodynamics because the steam is having heat energy. This nuclear power plant is also used to produce the energy, electrical energy. In that case, we are using heat energy which is liberated during nuclear, that means splitting actions. Yes, in those cases energy, enormous energy is liberated. That energy is used to convert the water into steam. Then that steam is used to run the turbine. Yes, once the turbine is rotating, that is called as the mechanical energy. In this case, in nuclear power plant, first the chemical energies gets converted into heat energy. That heat energy in turn gets converted into mechanical energy. After that, that mechanical energy in turn gets converted into electrical energy. In that case, by using thermodynamics. Like that, gas turbines. In the gas turbines, the gas is having a heat energy. Gas is having a heat energy. Yes, that heat energy gets converted into mechanical energy. Here, turbine, it is a device which converts the heat energy into mechanical energy. Yes, that mechanical energy in turn gets converted into electrical energy. Yes, after that, IC engine. What you are studying now, IC engine comes under the thermodynamics. This is one application of the thermodynamics. Then air conditioning system. That is one application of thermodynamics. In the air conditioning systems, what we are using is, here we are extracting the heat from the room to be cooled. Then we are sending that heat to the atmosphere. Continuously we are extracting the heat from the room to be cooled and it send it to the atmosphere. Like this, by using the thermodynamics in the air conditioning systems. Then next example is refrigeration. In the refrigeration also, continuously we are extracting the heat from the substance to be cooled, that is inside the compartment, and that heat is sent into the atmosphere. That heat is sent into the atmosphere. Next is compressors. In the compressors also we are using a thermodynamic systems. Thermodynamic systems. These are the examples of thermodynamics and etc. Many examples are there. Many devices are there. All those devices are comes under the thermodynamics. If you consider boiler, that boiler comes under the thermodynamics. That is one system. Yes. If you consider turbine, that is one system that comes under the thermodynamics. It is a device which converts one form of or available form of energy into mechanical energy. Again, that mechanical energy in turn gets converted into electrical energy. This is some introduction regarding thermodynamics. In the examination, if we ask what is thermodynamics and briefly explain the thermodynamics, in that case, we should write what is thermodynamic. The thermodynamic is divided into two words. One is therm and second one is dynamics. Therm means the heat or the energy and the dynamics means the flow. That energy flow or the heat flow is called, or the heat transfer is called as the thermodynamics. After that, the applications of the thermodynamics, where you have used the thermodynamics. Yes, I hope it's clear to you. Next is very important topic, thermodynamic system, system boundary and surroundings. This is very important. First, you should know what is system, what is system boundary, and what is surroundings. This is a very important concept. Already studied in your first PUC. Yes. First, we are going to the system. In the definition, you just go through the definition. A system is defined as an enclosed space which has been separated for the purpose of analysis, observation, and inference. This is one system. This is an enclosed space. This is an enclosed space which has been separated for the purpose of analysis. If you want to do any analysis in this space, you can do, or observations and inference, any research work. If you want to perform in this space, you can perform the research work also. Such space is called as a system. Best example for the system is your IC engine. IC engine, one system. And the best example is a refrigerator and air conditioning system. A refrigerator, one system, and air conditioning system and the one system. Next best example is boiler, that is one system. Next best example is turbine, that is one system. Next best example is your mobile, that is one system. Best example is your laptop, that is one system. Best example is your classroom, that is one system. Yes, if you consider any device that comes under one system, that comes under one system. Okay, in your classroom, if I using a projector, that projector is also one system. Yes, understood? I hope it's clear to you. Next is system boundary. Go through the definition. The envelope for the system is called as the system boundary. Whatever the system is there, that system is covered. Yes, that covered envelope is called as a system boundary. That cover is called as a system boundary. This is a system. The system is covered. Yes, that cover is called as the system boundary. The envelope for the system is called as system boundary. Best example for system boundary is, if you consider your mobile. For that mobile, you are using one cover for safety purpose. If that mobile is a system, whatever the cover you are using, that cover is a system boundary. That cover is a system boundary. If you consider your laptop, for that laptop you are using one cover. Yes, for that laptop you are using one cover. Here the laptop is a system, that cover is a system boundary. That cover is a system boundary. If you consider your classroom, if your classroom is a system, yes, if a classroom is a system, four walls are there. Those four walls are the system boundary. Those four walls are the system boundary. If you consider your IC engine, whatever the space is there inside the cylinder, that space is a system, and the cover, that is a cylinder outer surface, is called as system boundary. Cylinder outer surface is called as system boundary. I hope it's clear to you. Next is surroundings. This is very important. Go through the definition. The volume around the envelope is called as surroundings. The volume around the envelope is called as surroundings. Go through here figure. This is system. System is covered by an envelope, that is called as system boundary. Whatever the space outside the system boundary, whatever the space outside the system boundary, all the space is called as surroundings. All the space is called as surroundings, whatever it is. If you consider your classroom as a system, that classroom is covered by four walls. Yes, after the four walls, whatever the space is there outside, yes, all that space comes under the surroundings. All that space comes under the surroundings. If you consider your mobile is one system. Yes, your mobile is covered by an cover, that is called a system boundary. Whatever the space is there outside the cover, all the space comes under the surroundings. Whatever it is, either 1 kilometer, 2 kilometer, 3 kilometer, 100 kilometer, that comes under the surroundings. That comes under the surroundings. Even though in the surroundings many devices are there, many equipments are there, all those comes under the surroundings. All those comes under the surroundings. How to remember system, system boundary, and surroundings? Suppose if you are writing a letter, suppose if you are staying in your hostel, if you are staying in your hostel, you want to write a letter to your parents. What you are doing? First, you are writing that letter. Whatever the matter you want to express to your parents, you just write that matter in a paper. Yes, whatever the matter you have written in that paper, that matter is, or that paper is called as a system. That paper is called as a system. After completing the writings, you're placing that letter in the cover, right? That cover is called as a system boundary. That cover is called as a system boundary. And whatever the space is there outside that cover, outside the envelope, that is called as a surroundings. That is called as surroundings. I hope it's clear to you. And the best to remember is, if you want to write a letter to your HOD, whatever the things you are writing in a paper, that paper is a system. After completing the writings, you're placing that one in the envelope. That envelope is a system boundary. And whatever the space is there outside the envelope, that is called as surroundings. And the best example for system, system boundary, and surrounding is our body. In many cases, our body is the best example for the thermodynamics. In many cases, our body is the best example for the thermodynamics. Our body is one system. Our body is one system. Our body is covered by a skin. That skin is called as a system boundary. That skin is called as system boundary. And whatever the space is there outside the skin, All the space is called as surroundings. All the space is called as surroundings. Now it's understood to you. System boundary, surroundings. Next, we'll move to the next concept. The thermodynamics system can be classified into three types. First one is open system, second one is closed system, and third one is isolated system. Thermodynamic system can be classified into three types. First one is open system, second one is closed system, and third one is isolated system. What is open system? An open system is a system in which there is both energy and mass crosses the boundary of the system. Go through the definition again. An open system is a system in which there is both mass as well as energy crosses the boundary of the system. Such systems are called as open system. Such systems are called as open system. In the name itself, it shows open. Open means, you just remember, open means both mass as well as energy cross the boundary of the system. You just go through the figure. This is a system. System is covered by a surround system boundary envelope, that is called a system boundary. Whatever the space outside the system boundary is surroundings, right? If it is an open system, that system boundary is open. System boundary is open. Once the system boundary is open, both mass is entering from surrounding to the system and energy is entering from surrounding to the system, and also both mass is coming out from the system to the surroundings and energy is coming from system to the surrounding. Such systems are called as open system. Such systems are called as open system. Best example for open system is water flowing in a pipeline. Water flowing in a pipeline, this is the best example for open system. In this case, if you consider this pipeline is a system, here this pipeline is a system, this pipeline is open. You just go here, this is a pipeline, just go here, this is a pipeline, right? This is a system. Water is entering into the pipeline, right? And water is coming out from the pipeline. Here water is having a mass flow rate. In addition to mass flow rate, it is having a kinetic energy. Yes, it is having a velocity, right? It is having a velocity. Water is having a mass flow rate and also it is having a velocity, certain velocity. It is having mass flow rate and also it is having velocity. That indicates that mass flow rate enters, that is mass in to the pipe, velocity in through the water, velocity is there, right? Along with the water, it is having velocity. That velocity is nothing but the kinetic energy. Kinetic energy equal to half mv square. Kinetic energy directly proportional to the velocity of the water square, right? If it is 5 meter per second, kinetic energy equal to half m into 5 square, right? Like that, here a pipeline is a system. Here the water is enter from outside to the pipeline and also coming out from pipeline to the outside. Yes, both mass is enter and also along with the mass energy is enter. That energy is nothing but a kinetic energy. That energy is nothing but a kinetic energy. Such systems are called as open system. Such systems are called as open system. And the best example is steam is flowing in a turbine. Here steam is a, turbine is a system. Here turbine is a system. Steam is having a heat energy. Steam is having a heat energy and also steam is having some mass flow rate. Yes, both mass as well as heat energies enter into the turbine and also both mass as well as heat energies coming out of the turbine. Here turbine is a system. Both mass is enter into its turbine and also heat energies enter into turbine. Both mass is coming out of the turbine and also heat energy is coming out of this turbine. Such systems are called as open system. Such systems are called as open system. And the best example for open system is fountain pen while writing. Fountain pen while writing. Whatever the pen you are using for writing, that pen is comes under open system. Why it is open system? When you are starting writing on the paper, ink is coming out, right? From that pen, ink is coming out. That is a mass. And that pen is moving with a certain velocity. Your hand is moving with a certain velocity while writing. Yes, that band is moving with a certain velocity. It is having a kinetic energy. Both mass is coming as well as kinetic energy. Such systems are called as open system. Not only kinetic energy, whatever the energy it is. Not only kinetic energy, whatever the, either it might be potential energy, or it might be heat energy, or it might be mechanical energy. Whatever the energy, it cross the system boundary from surrounding to system or from system to surroundings. Such systems are called as open system. Such systems are called as open system. Next is closed system. What is closed system? Go through the definition. A closed system is a system in which there is only energy interaction but no mass interaction. Again, go through the definition. A closed system is a system in which there is only energy interaction but no mass interaction. What it indicates? Closed. In the name itself indicates the system is perfectly closed. In the name itself indicates the system is perfectly closed. Once the system is perfectly closed, there is no mass enter into the system and no mass coming out of the system. Once the system is perfectly closed, there is no space to mass enter into system from surrounding to system, and also there is no mass coming out from system to the surroundings. But only there is an energy interaction. Even though it is a closed system, there is a chance of energy interaction from system to the surrounding or from surrounding to the system. Such systems are called as closed system. Such systems are called as closed system. Best example for closed system is, if you consider a container. If you consider a container, assume that this is a container, right? Inside the container, here this is the water is there. Inside the container, water is there. Yes, this water temperature is around 100 degrees Celsius. This container is perfectly closed. This container is made up of metallic sheet, that is a mild steel. Container is made up of mild steel. Inside the container, water is there, hot water around 100 degrees Celsius. Hot water around 100 degrees Celsius. Atmospheric temperature is 25 to 30 degrees Celsius. Because of the temperature difference, because of the temperature difference, there is an heat transfer. There is an heat transfer from higher temperature to lower temperature. That is from hot water to atmosphere through the container walls. Through the container walls. But the quantity of the water which is there inside the container, that is same. That quantity of the water will not get changed. Even though there is a change of temperature because of the heat transfer, there is a change of temperature from higher temperature to lower temperature, but there is no mass transfer. Why there is no mass transfer? Because this container is perfectly closed. For that reason, there is no mass transfer, only there is an energy transfer. Such systems are called as closed systems. Such systems are called as closed system. And the best example is sun. If you consider sun, here sun, okay, continuously sun is emitting heat energy to the earth's surface, but the position of the sun is in the same position. There is no change of the position. Only sun is emitting heat energy. There is no mass interaction between sun to the earth. Only there is an energy interaction, heat energy interaction between sun to the earth surface. Such systems are comes under open system. And the best example is television while operating. Your television is fixed in a wall on the wall. In a particular position, you are placing your television, but you are using a remote. You're using a remote to operate the television. Only there is an energy interaction between the television and the remote, but there is no mass interaction between television and remote. Such systems are comes under closed system. Yes, if there is only energy interaction, that is closed system. If both energy and mass interaction, that is open system. Next best example is transformer while working. Transformer, many of you have seen the transformer on the road. Yes, many of you have seen the transformer. The transformer is placed in a fixed position. The transformer is not moving. We are placing in a fixed position, but there is an energy transfer, electrical energy transfer from the transformer to the different positions or different places, right? We are getting the electrical energy to the individual house from the transformer. That is, there is an energy interaction from the transformer to the house, but there is no mass interaction. Transformer is not moving from that place to your house. Such systems are called as closed system. Such systems are called as closed system. Next comes under the isolated system. This is very important. Isolated system. What is isolated? In the name itself, isolated. It indicates that it is perfectly closed. First one is it is perfectly closed and it is perfectly insulated. Perfectly closed and perfectly insulated. Such systems are called as isolated system. Yes, go through the definition. An isolated system is one in which there is no mass transfer or energy transfer across the boundary. An isolated system is one in which there is no mass transfer or energy transfer across the boundary. Such systems are called as isolated system. Best example is this is a system. This is surrounding. System and surroundings are separated by system boundary. Yes, the system boundary is perfectly closed. System boundary is perfectly closed, and also it is perfectly insulated, and also it is perfectly insulated. First one, it is perfectly closed. Once the system is perfectly closed, there is no chance to transfer the mass from system to the surrounding or from surrounding to the system. Next, it is perfectly insulated. Once it is perfectly insulated, there is no chance to transfer the energy from system to the surroundings or from surroundings to the system. Once it is perfectly closed, there is no chance to mass transfer from system to the surrounding or from surrounding to the system. Once it is perfectly insulated, there is no chance of energy transfer from system to the surrounding or from surrounding to the system. Such systems are called as isolated systems. Such systems are called as isolated system. Best example for isolated system is coffee in a thermos flask. Coffee in a thermos flask. How it is best example is just observe here. Assume that this is a thermos flask. This is perfectly closed. And the one layer, I'll draw another one layer. This is perfectly insulated. This is perfectly closed and perfectly insulated. Inside the closed container, hot coffee is there. Assume that this is perfectly closed container and perfectly insulated. Inside that hot coffee is there. Thermos flask. Assume that this is a thermos flask. Thermos flask, it is perfectly closed and perfectly insulated. And inside the thermos flask, hot coffee is there. Assume that hot coffee temperature is around 90 degrees Celsius. 90 degrees Celsius. Atmospheric temperature, assume that it is 28 to 30 degrees Celsius. Yes, even though there is a temperature difference between hot coffee and atmosphere, there is no chance to transfer the heat. Why there is no chance to transfer the heat? It is perfectly insulated. It is perfectly insulated. And also there is no chance to transfer the coffee from that container to the atmosphere, or there is no chance to transfer any substance from outside to the thermos flask because it is perfectly closed. Such systems are called as isolated systems. Such systems are called as isolated systems. I hope it's clear to you. I'll wind off this session today here itself. Yes, in the next session, I'll continue the further part. Thank you. Thank you, one and all.